Okay, good morning, everybody. Can you hear me?
Good morning, sir. Yes, sir.
Yes, sir. Good morning, sir.
Okay, so last day we discussed about the Fourier integral. I think this is the last question we discussed. Am I correct?
Yes, sir.
Okay. So now we are so familiar with that how to find out the complex form of the Fourier series, as well as how we are going to convert to the Fourier series to the Fourier integrals. That's what last day we discussed. And after that, we discussed some example. This is the last example. Today, I'm going to discuss the Fourier transform. Actually, Fourier. Before that, I want to talk about the what we call Fourier sine integrals as well as cosine integral. So I think that note also I share with you. So I believe you maybe follow it. This is the note which I am going to share with you. I think you remember when you discuss about the Fourier series, then we are talking about the Fourier sine series as well as Fourier cosine series. The similar, we are talking about the Fourier integrals. Now we are going to talk about the discuss about the Fourier sine integral as well as cosine integral. If the given function is the odd function or maybe the even function, I believe you have idea what the meaning of the odd function, which already we discussed in second semester. So, but here I mentioned that that what is the meaning of the odd function as well as even function. And again, you discuss about the orthogonal condition for the Fourier series. When you talk about the Fourier series in second semester, same concept, same definition here we are using. You can see if fx is odd function, that is the function if it is odd, you know that if we substitute minus x or if we substitute the minus variable for the function, so the result of that is minus fx. So if it is, we call that function is odd function. And also we talk about if that particular function is odd function, that is not symmetric around the y-axis, because graphical representation also we discussed in the second semester. Here also we are talking about the same thing. The advantage of identify the function or the given function is an odd function or even function for the reduce our work of particular example. So just try because you learn the Fourier integral coefficients, or maybe you find out the Fourier integral coefficients of some example for the last day. So you know that here we have a alpha is the Fourier integral coefficients we have, that is defined as 1 over phi, actually L should give me a phi, because L we replace minus 2 L to L, entire period we define as capital T. The capital T again we divide as the period as L. Then here the last day we again replace with that another, we have a special period phi like that. So we can define A alpha as 1 over 5 minus infinity to infinity fv cos v alpha v dv. If you want to, you can replace v as a x here. There's no any problems, but I want to show that there is a some alpha value. Alpha is actually the frequency. Some books or maybe some references which I given to you. Sometimes it may have defined cos omega v or maybe cos omega x instead of the alpha v. That is notation, don't worry about that. But here I am going to use about the alpha. Okay, that's the frequency value of the function. Then you know that if the given function is odd function, and already we know that cosine function is a even function. Multiplication of odd and even function is equal to the odd function. Then if we take the integral of the odd function from minus infinity to plus infinity, or maybe minus L to plus L, exactly that is goes to 0. So therefore the Fourier integral coefficients A alpha goes to 0. And also the second, the definition for the alpha, B alpha. So we have 1 over 5 minus infinity plus infinity f e sine alpha v dv. Again, if the given function is an odd function, and again we know that sine alpha v is a odd function, then the multiplication of odd two functions become a even function. Then there should be the value for that. And also, I think you remember second semester mathematics. If you have the, I am not going to remind us the same, or maybe through the everything now. I just remind you. B alpha equal to divide by 5, because if we have the minus infinity to plus infinity, we can write down 0 to infinity 2 times of that particular integral function. Then that function you can rewrite. If particular function is, or maybe the fv function is odd function, you can write down B alpha equal to divide by 5, 0 to infinity fv sine alpha v dv, denote as equation 7. You have to keep this equation 7, because after that I am going to use this equation. And therefore the Fourier sine integral representation of the odd function, we can write down fx equal or 0 to infinity b alpha sine alpha v d alpha. That is not as equation 8. The similar, if the given function is even function, a alpha you can write down 2 divided by 5, 0 to infinity if we cos alpha v dv, because you know that if the given function is, or maybe if v function is even function, cosine also even function, then the multiplication of that particular two function is again even, then you can write down that one as a combination of the two function even, so you can write down the 2 times of the integral function. And also at that time b alpha goes 0, because why? If the given function is, or maybe if v is an even function, sine function is odd function, combination of that function is odd function, then integral minus infinity to plus infinity, that becomes 0. That's what, or maybe that's why the b alpha goes to 0 here. And the particular integral coefficients, or maybe the a alpha, we denote as the equation 9. Then similarly, we can write down the Fourier integral for the cosine function, of course, cosine integral like fx equals 0 to infinity a alpha cos alpha x d. That is not equation 10. It is clear to you?
Yes, sir.
Yes, sir.
Okay, then what we discuss integral functions, we denote the two component, that is a cosine integral as well as a sine integral. Okay, Then the other one, application of that function, find the Fourier integral representation of the given function. So what I want to explain here, like the previous example of the example which we discussed previous over the previous day, previous class. So the similar kind of question they ask in find the Fourier integral representation of the any given function f(x). Right. If it is possible to plot this function, and then I will explain how we are going to reduce our work by considering even or odd function. Please plot this function first. Can you see my the camera? Yes.
Yes, sir.
Okay. So given function is fx, fx equal. I'm talking about the example 7. So 0 minus 1, 1, 0. If x less than minus 5, if x between 5 and 0, and also if x between 0 and 5 and x greater than 5. So how we can plot this function? The function is think about the minus 5 to plus 5, and minus 5 less than minus 5 value of the function becomes 0, that means here, and 5 to 0, 5 to 0 the function value is minus 1, that means maybe here minus 1, and again 0 to 5 function value is 1, that is like this. After that function becomes 0. This is the behavior of the function we have. When you just look at this function, is it possible to identify this function is an even function or odd function? What is this function?
Uh,
It's an odd function.
It's an odd function.
odd.
Why? Because
Because even function fx equals f minus x
no, even function
in
fx
even function
even function fx equal
f minus x.
f minus x, yes. So if you substitute the f minus x, that is equal fx for the even function. But in this case, if we substitute f minus x, we have the minus fx function, right, for this function. So exactly this is then odd function. If it is odd function, so see the we can reduce, because the you know that if you are going to find out the integral Fourier integral, so you need to find out the two coefficients a alpha as well as b alpha. But the previous theorems I explained to you, if the given function is odd function, exactly what happened? B component goes to 0, no, coefficient of B goes to 0. So therefore you can write down Since fx is an odd function, what you can write down, a alpha equals 0. Then what we have, b alpha equal 2 divided by 5, 0 to infinity, fv sine alpha v dv. It is clear to you?
Yes, sir.
Yeah, half of the work we can reduce. Half of the work we can reduce if you clearly identify the particular function is or even. Right. Now, you know the function. Although we have the 0 to infinity, actually the 0 to 5, only we have the function is defined for the positive side, other goes to 0. Hence, you can write down this function as 2 into 5, 0 to 5, 2 divided by 5, 0 to 5. If v means actually now it is 1 into sine alpha v dv. So now you can take the integration of this. Can you take the integration and let me know the answer? Okay, actually that is only the hint I want to give to you. They are the all words you must know. Let me know the answer.
One minus cos alpha phi divided by alpha
1
times 2
minus,
pi.
okay, but the answer is every day is some problem for the Wi-Fi. I don't know what happened. Right, I believe clear now, right? My note is okay now, clear?
Yes, sir.
So the answer is today. I'm not going to simplify. You must know how to simplify this. 2 divided by phi alpha into 1 minus cos phi alpha. Am I correct, Krishna? Krishna? Am
Yes,
I
sir.
correct? Okay. Then you need to find out the Fourier integral representation. Write down therefore Fourier integral representation of fx is, what is that? Fx equal integral 0 to infinity a alpha cos alpha x, no, plus b alpha sin alpha x into d alpha we have. That is the Fourier integral representation, but we know that a alpha goes to 0 because of the given function is odd function. The remaining only b alpha. So this confirms only remaining. So you can write down hence fx equal, what is that? 0 to infinity b alpha sin alpha x d alpha B alpha means you know the value. You can substitute that value here. That is 0 to infinity. 1 minus cos phi alpha divided by alpha. That constant you can take out 2 divided by pi. And sine alpha x b alpha. That's a Fourier integral representation of x. How you can find out the convergence value of this integral of the given point? Example, if you want to find out the convergence of this Fourier integral at think about x equal minus pi. Value of Fourier integral at x equal minus pi. What is the value? How we can find it?
If minus 5 plus, if minus 5 minus divided by 2?
Yes, because you can see the minus 1 means this is the point we have. No? That's a discontinuous point. 0, that will be changed as a minus 1. Then that will be converged, or maybe the function, integral function will be converged to the value. No? Which value? F minus pi plus f plus pi. You are not plus pi, okay. Yeah, pi minus plus, minus divided by 2. So that means 0 minus half divided by 2, that is converged to half. That means when we just substitute x equal 5 for this function, this one is 5 now. So no need to take the simplify this one exactly, that this integral function will be converged to this result. Understand now?
Yes, sir.
Okay, no need to recalculate this value exactly, that will be converted to this one. But if you want to find out the convergence of this integral function at x equal 5 over 2, what will be the value? Sorry. What is the definition we learned for that?
Okay.
I didn't get, I cannot hear you.
1?
That is the one, okay? Because of that, the point is you can see 5 over 2 means here. So function value is always one between that. That is a continuous function. But if you want to converge, find out the value of this one at 5, again this continuous point. So you can find out the left hand values and the right hand values of the function divided by 2, the average value. So that's what we want to learn from this. Right. So then I come to the question number 8, I think. Do you want to talk about that? Question number 8. Okay, I will come to that because that is something I will put that one also. That is, I want to give the something else because the giving the example is different idea I want to give. That's what I put that question also. Right, anyway, question number 8. So question number 8 means you know that the result is 1 and 0 between 0 and 5 as well as x greater than 5. That is the positive domain the function has defined. So again, if you are going to plot this function, the plotting is most advantage, not need, that's not compulsory. But anyway, if you can plot this function, you can identify what is the behavior of this function very easily. So that's the idea. So therefore, if you are going to plot this function, For the exams also, sometimes maybe asking the plot, or maybe they are not asking this, asking about the solution of the problem. The better you plot that function, so easily you can identify what the mean of this one. So 0 to 5 is a function. The question is asking find the Fourier sine and cosine integral. Am I correct? Yeah. So find the Fourier sine and cosine integral for the function. So this is the question. Just add document to you. So the question is asking that find the sine and cosine integral representation of this function. So Fourier, think about the, we are going to find out the Fourier sine representation at first, okay? Part of the one. We are going to find out the Fourier sine representation. Okay. How we are going to find out the Fourier sine representation? At that time, what should happen? If you want to show the Fourier sine representation, the particular fx function should be what?
Even?
Not
Odd.
even. That should be odd function. Yes, this function should be odd function. Then my question is this function is odd? The question is asking find the Fourier sine integral representation of fx function. So if you want to find out the Fourier sine representation of this fx function, the function should be odd function. Then my question is this function odd?
It's not given.
Yeah, it is not odd function. It is not given. We cannot identify the particular function is even or odd if we have this kind of graph. Then what you want to do is you have to extend the graph. You have to extend the graph to become an odd function. How you want to extend the graph? You know that if you want to create the even function, that function is not symmetric around the y-axis, then what I am going to do is I am going to extend this function to satisfy the condition. Which conditions? F minus x equal minus fx condition. That should be satisfied for this function. So this is the given area owing with the given function. So what I will do is here phi, I extend up to the minus phi for the minus 1. So now you can see if we can plot this function, if we can extend this function, this is exactly satisfy this condition. Hence, this function is even function, right? Clear now? This can be, if you want to, you can write down odd extension. Odd extension of the function. Now the function is even function. Clear now? Right. If it is assumed, if we extend this function like this format, now our target is to find out the sine function, sine integral. The sine integral representation means exactly cosine terms should go to 0. That means a alpha need to go 0, right? Okay, write down. Then the Fourier representation of fx is. Then we can write down. Then Fourier representation of fx is fx equal 0 to infinity b alpha sine alpha x d alpha. As I mentioned before, sometimes because here I identify the frequencies alpha, sometimes the frequencies normally we are going to use about the v, or maybe sometimes it may be omega. This way you can write down if you want 0 to infinity v omega sine omega x d omega fx. That's possible, okay, because it's only the notation I'm going to change for these two functions. And that depends on you. one variable you can use it. And then if you denote this way, what you can say, B omega or B alpha equal 2 divided by 5, 0 to 5. If V sine omega V dV. Other than that, B alpha sine alpha V dV. Those are notation, don't worry about that. Anything you can do it, any notation you can use, change. Why I want to explain it because some references which are given to you have used omega. That's what I'm talking. But anyway, now you can see, although we extend the function, minus 5 to plus 5, actually now what you have, what the function have now, initially what we want to find out the integral is represented as positive, no? 0 to 5 or 0 to infinity. 0 to infinity means the given value entire domain, but the function is defined 0 to 1. Therefore, the 0 to 5, sorry, 0 to 5. Therefore, 0 to 5 only we need to take the integral. So now we can substitute the value 2 divided by 5, 0 to 5. Sorry. If v means now 1 and sine omega v dv. I think now we can simplify. Let me know the answer for this function, this value. V omega equal 2 divided by 5. What is the answer?
Two divided by 5 alpha times 1 minus cos alpha 5.
Okay, 1 minus cos omega 5, right? It's also alpha, yes.
Yes,
If you
sir.
want to, yeah, alpha, yes, so omega 5 divided by omega. Correct, good. So this is the integral coefficients. Now we have to substitute that integral coefficient for the function. This one. So you substitute that value. Therefore, Fourier sine integral representation is fx equal 0 to infinity, 2 over 5 you can take them out, 1 minus cos omega 5 divided by omega into sine omega x d omega. So this is the answer you have. It is clear? Okay. Good. And again, you need to find out the Fourier cosine integral of the particular function, right? Second part of the question. Fourier cosine integral. For that, what happened? What should they have? Should they have the even function, no? Am I correct? For that, you should have the even function. If you want to find the even function of that scenario, what you want to do is, actually the given function is now in this domain. So actually, this is the domain we have 0 to 5 fx. Now we should have My note is clear to you? Hello?
It's a bit unclear, sir.
So that was something was happened, I don't know. I think now okay?
Yes, sir.
Okay, so then what I want to do is I want to create the even function. At that time, I extend the function like this, -5 to +5. Now you can see this function is symmetric around the y-axis. So if it is, you can write down if you want to. In this case, we have to extend this function, or maybe a fixed function, as an even function. Okay. So then this is the case we have. After that, what you want to do is you need to find out the Fourier integral cosine representation of this function. For that, you know that a alpha or maybe omega is defined as a omega, you know, the omega, no? 2 divided by 5, 0 to 5, fv cos omega v dv. So now we substitute the value, substitute the given value for this function and simplify this. Then the 2 divided by 5, 0 to 5, that is 1 into cos omega v dv. Now let me know the answer for this.
It's
Yeah.
2 over 5 sine alpha phi divided by alpha.
Okay.
So is it 0?
No, it is not 0. Why?
Because it's sine alpha phi?
No, if it is alpha n only, you are going to 0.
Okay.
N means integer, right? So you cannot become the 0 now here, like the previous one.
Okay, sir. Thank you.
Sine omega divided by omega. Because omega is not integers, it means omega means frequency, some wave. Okay. So we don't know what the frequency is in the different scenario. Right. So this is the value. So then what you want to do is you have to substitute that value to the Fourier integral function, that is fx equal 0 to infinity a omega cos omega x d omega 0 to infinity. So 2 divided by 5 you can take it out. Here we have sine omega 5 omega divided by omega into cos omega x d omega. This is the Fourier cosine representation of the given fx function. Again, you can see the different domain. You can identify this is the 0, this one is 0. If you are asking about the function convergence of this function at this point, or sometimes we ask the convergence of this function of that particular, whatever the point, you need to use the particular given theorems to identify the convergence or maybe the value to find out the value of this integral. Right. It is clear? Any question you want to ask? Sir. Hello. Good morning, sir. Masa lecture again, sir. Can sir? හිට මම ඒ සමානට බොහෝ දිනස ඇයි සර් ඕකේ මම හෙට කොහොමත් මට ලෙක්චර් එකක් තියෙනවා මම එනවා සර්. කීයද සර් එක්සෑම් එක තියෙන්නේ? එකට. කමක් නැහැ සර් මම කරන්න. හරි සර්. ඕකේ ඕකේ. මම සර් හරි සර් ඕකේ ඕකේ. Okay, sorry for that. All right, so then so yeah, the next question is you can see this is the question number 9 using the Fourier integral formula to prove that this integral to prove the given result. Here you can see why I want to change the factors. There I used alpha and I consider the omega here. This next example here you can see really omega. So I want to show that any the notation you can use here. But then just we look at this one example which you want to show, I mean the result which you want to show. There we have the omega. With practice, normally you are maybe using about the alpha value. It doesn't matter. But although you use the alpha for your calculation as a final result, when you write down that kind of example for the exam as a final result, please substitute this value and so what you are going to do. Any notation you can use for the calculation, but finally you have to substitute the existing variable and show the given actual result. So that's what I want to explain here. So this is another example. The simplification is little bit different than to the previous example, because different example I use a different techniques here. Something I want to explain to you. Other than that, you may be troubled or maybe you are wasting your time, because most of the students you are telling that this time is not enough. The reason is this one. If you are giving the open question, so no need to do the all calculations. Please use the definition and the theorems which I am going to given to you, which I give to you. Or what I want to do is you just really mention it. Why you are doing this calculation, why you are reducing your work, that is most important. Other than that, don't just do the work and spending your time. Finally, you blame me, the given time is not enough. The reason is this, that's what I want to explain here. Half of the times you can reduce if you really understand the question. So you can see, if you are going to write down the both calculation here, you spend in at least 5 minutes spending. So that is your time for the examination purpose. That is more valuable time. So therefore, don't spend that kind of time. Reduce as much as possible your work. Actually, the reduce work means don't no need to the reduce a step or maybe the step of the algorithm. Algorithm you have to clearly mention, but clearly understand what's the behind the screen. So therefore, if you really explain it, so you can reduce the your time. So that's what I'm explained to you. And also my question is the question which I'm going to prepare for the examination for the last the exam papers you can collect it. That is also there. When you just look at the exams are sometimes you may be doing that hard question or even no, it is not hard question. Clearly follow the definition and the theorems which I given to you. So what you will do is just really observe, analyze given question, check whether how you are going to enter. If you just enter that some component exactly, that will be easily continuing. But entering is the problem you have to enter the question. So what you do is you should have all the definition, meaning of the definition, and you must know the theorem. That is most important. Other than that, question paper is not hard. And also the way we are going to give the exam question means normally first two parts very simple, and exactly that can do any people if you are in my lectures. And the other one, other steps, last step of all the questions, that is a challenging part for you. So if you are really do your work not participate in the class. If you are really work, you do a work, if you really submit your own work uh, as assignments or in the tutorial, then only you can gather that knowledge so that people can take. So then that all grade will be dependent on your work you are working in the class. So this why I want to mention that, because you can see that today class till now 85 students we have. Okay, so therefore what you do is the participate of the class is most important, because just to read the note, I don't believe you can get the necessary knowledge. You can get something, for just uh, get through the exam, yes. But if your target is, as I mentioned, your target should be earn the class. It may be at least second lower class, but I'm motivate you to get the first class. If you are trying to get the first class, at least you will earn the second number. So therefore, please do hard work. That's most important, right? Then the second example, nine example, based on the some technique which I'm going to use to calculation. So let's see how we can use that part also. So here use about the use the integral Fourier integral formula to that the given result. Right. When you look at this one, tell me what you are going to do. Can you identify this is the integral transform, Fourier integral transform? Yes or no?
Yes, sir.
Yes. And also, can you identify this is the cosine Fourier integral transform asking or not?
Yes.
Yes.
Cosine?
Why? Yes. This asking. The question is not asking that. You can see use the Fourier integral formula for this one. No? Using the Fourier integral formula, prove that. Fourier integral formula you have to use and prove that this. How we are going to reduce your work? The question asking to show this one, when you look at this example, you want to see this function, you can see depend on, or this integral will be depend on cos omega x. Cos omega x depend means exactly that this is the Fourier cosine integral representation. That's the asking. Okay. If you clearly analyze this one, exactly half of the question, half of the your work is reduced. Other than that, if you are starting with the Fourier integral formula representation, you need to determine the values, both values, spending your times. Finally, we'll get this answer if you did correctly calculation. Other than that, so you will spend your time. But anyway, when you just look at this one, you must understand this done the Fourier, the cosine integral representation. Okay, so then you are going to do your calculation. What the fx is here? So this is the fx function you have, right? Let's see how we can do it. If you want to, you can write down the answer for this question to identify whether this function is Fourier cosine or sine transform. Write down in this integral representation, the cos omega x in this integral representation the cos omega x term represent that to find out the find out the Fourier cosine formula. Fourier cosine formula for the function e to the power minus 6 cos 6 for the function e to the power minus 6 cos 6. So now itself you are reduced the half of your work. Then what you do is you have to find out only the alpha. Hence you can write down Fourier cosine integral representation, hence Fourier cosine integral representation for fx function equal fx equal 0 to infinity a alpha cos alpha x d alpha. Actually, that is again I write down the things which I keep in mind. Now look at this one. Again, the what is the question we have? Your question is depend on. Look at this one. Your question is depend on omega. Hence, actually, this better you write down this one. And this is omega, and this is omega. No? Then the final result we can see. Other than that, alpha I have to change as omega. Yeah. Okay. So that is the value you have. Then here, a alpha is the value you need to, a omega is the value you need to determine. So you need to find out that value now. So this is the definition. Right now, where a omega equal to divided by 5, 0 to infinity. Why? Because 2 divided by 5, we already identified this is the half of the Fourier integral. That means Fourier cosine integral. Actually, that means this identify the given function is even function. That is other meaning. Okay. So omega if we cos omega v dv and 2 divided by 5 0 to infinity fv fx means this one fv means e to the power v cos omega v dv a omega. Here I used some technique to simplify this. If you want to, you can use another technique. Here I used some different technique to get this answer. What is my technique is just I write down 2 divided by 5. This is a omega. 2 divided by 5. What we want to integral 0 to infinity. This cos, no? Cos plus sine cos A cos B plus sine A sine B, or maybe cos A cos B minus sine A sine B format. That will be the easy way you can simplify the question. What I want to do here, I add this two value. What is two value? I write down here cos omega V cos B, that means these two terms, I subtract some value. What is that? Sine omega V, sine V, right? That is the first term. And again I write down cos omega V, cos V, plus sine omega V, sine V, dV. If we did that one, you can see this to this cancel. Sine omega V to sine V, both terms positive and negative, opposite signs, that will be cancelled. Then we have 2 times this component, 2 times cos omega V and cos V. So then it going to divide by 2 to get that previous result. So then what I want to do is, this is the e to the power minus we have, I divide that by 2. It is clear?
Yes, sir.
Okay. So if we did that calculation, what you have in the 2 to 2 cancel, then half 1 over 5 integral 0 to infinity. For this terms you can write down cos v omega plus 1. Okay. And this terms you can write down, what is that? Plus cos omega v minus v. This omega v plus v, I take the v outside. This omega v minus, if you want, you can take v outside also here at once. Right. There's the dv there. It is clear? Okay. Right. Now then it is easy to simplify. That some term is missing, e to the power v is missing, right? E to the power v minus v is missing there. Then you have the two terms, two integrals here, 1 over 5 into integral 0 to infinity e to the power minus v cos v omega plus 1 dv plus 0 to plus infinity e to the power minus v cos v omega minus 1 dv. The previous, what I want to do is, because previous case we have the sine and cosine three functions, that three functions are both are not reducible function after taking the integration. That three functions I want to convert to the two function. Now we can see here three function e to the power v cos omega v. Three function we have. But I reduce that to the two function fx gx format. Fx gx format. Understand now?
Yes, sir.
Okay, so now what I denote this one as the b1, this one as, so maybe i1, whatever the things I don't know, i1, this one as i2, integral 1 and integral 2. So I take the i1 outside, then i1 equal 0 to infinity e to the power minus v cos v plus omega plus 1 dv. Now we have to simplify this two function. Both are not reducible function after taking the derivative, but anyway you can convert to the two times you can take the integral by parts. So same function will come, then you can find out the value of the integral function. Okay, so what I want to do is use the integral by parts problem. So you have then minus e to the power minus v. I take the integration of this one, keeping the cosine function v omega plus 1. I substitute 0 to infinity minus 0 to infinity integrated function, this one minus e to the power minus v, derivative of second function, that is sine, no, minus minus sine v omega plus 1, and derivative of this one means omega plus 1, because function in function they are dv. It is clear?
Clear, sir.
Okay, for that I think I don't want help, that's simple. So then I take this one part of it and I can simplify that one. Again, I will take the integration by part this one, minus e to the power minus v cos v omega plus 1. I keep this value as it is. I can take the common value later on. This is minus 3 times minus, that means minus omega plus 1 is the common value. And take the integral of the remaining function again. That is minus e to the power minus v sine v omega plus 1, 0 to infinity, minus integration 0 to infinity, integrated function, that means this one, e to the power minus v sine v omega plus 1, oh, sorry, that should be cos, right? Cos v omega plus 1 into omega plus 1 dv. I believe you understand it. This is 5 page. Right, now we have to simplify this. Now look at this one again, the same function we have, that is I1. Then you can write down I1 equal this component, what you can write down there. You simplify this now. Omega v square. So then what you can write down here? You can write down I1 equal this minus e to the power minus v cos v into omega plus 1. This is plus omega plus 1 into e to the power minus v sine v omega plus 1. You have to substitute the limit 0 to infinity, 0 to infinity. Here again we have multiply this minus plus 3 times minus means minus you multiply this by this, that is omega plus 1 square into integral 0 to infinity e to the power minus v cos v omega plus 1 dv. Right. So then this is, you have what you have, substitute the limit upper and lower limit for these expressions. Infinity means e to the power minus infinity, that is goes to 0. This one also goes to 0. Then substitute the infinity, that goes to 0, right? Therefore, I1 equal, the first concept out will come to 0 minus, when you substitute 0, e to the power minus 0 means that is 1, cos 0 means 1, right? That means here minus 1 we have, sin 0 means 0, this is plus 0. Plus, this one means omega plus 1 square. The entire this component means again I1. Then this one means I1. So therefore, this terms you can take them out. I1 equal I1 into 1. This is minus, right? Sorry, this is minus. Then we come to plus here, plus omega plus 1 square equal this side minus, that becomes the plus 1. Then I1 equal what is that? 1 divided by 1 plus omega plus 1 square. That is I1 means, what is that integral component which I considered? You can see I1 means this one. I1 equal 0 to infinity to the power minus v cos v omega plus dv equal 1 over 1 plus omega plus 1 square. It is clear?
Yes, sir.
Some calculation we have to do. What I want to show that if you have the three functions for integrations, you want to reduce that to the 2 function by using this kind of calculation. That's what I am expecting for this question. You have to learn. Other calculation, I think, of course you can do it, but unless is in trouble. Right. Then again, you need to find out the I2 for the previous question. What is I2 means? We identify, you can see. I2 means the second part of this integral. That is I2 means you can write down 0 to infinity. We can write down if you want to say, right? And this also say I1 and I2. So then the I2 means you have e to the power minus v cos v omega minus 1 dv. Right. Again, integral by parts you have to apply. Then we use the integral minus e to the power minus v cos v omega minus 1 0 to infinity minus integral function e to the power minus v sin v omega minus 1. Hopefully the name that is sin and omega minus 1 dv. This is cos derivative means minus sign, right?
Yes, sir.
Okay, now go ahead. As similar, you can this as 0 to infinity. Then minus e to the power minus v cos v omega minus 1, 0 to infinity. If you want to, you can substitute the value. I keep as is because another term we can take for the second integral function. So here we have minus 3 times minus again minus omega 1 integration of this one minus e to the power minus v sine v omega minus 1 0 to infinity minus integration 0 to infinity integrated one, that means minus e to the power minus v derivative of sine, that is cos vw minus 1 omega minus 1 into dv. Sorry, correct? Am I correct?
Yes, sir.
Okay, now the like previous example, you can previous part you can take these two outside limit. So then you have minus e to the power minus v cos v omega minus 1. This is become plus omega minus 1 e to the power minus v sine v omega minus 1. That is 0 to infinity. And the next term, 3 times minus means minus omega minus 1 square 0 to infinity e to the power minus v cos v omega minus 1 dv. That is I2. So again substitute the limit, upper limit c infinity e to the power minus infinity goes to 0. Therefore, when you substitute the upper limit, that becomes 0. Then substitute the lower limit. When you substitute the lower limit, what happens? This is both 0, 0 plus 0 minus when you substitute the lower limit, that is 0 means this is minus 1. Minus 1, this one 0 means plus 0 minus omega minus 1 square. This component means I2, no? I2. And this one again is I2 equal this one. Then the I2 terms you can take an out. I2 equal 1 plus omega minus 1 square equal, this is 1. Please check my calculation. Am I correct?
Yes, sir.
You asking about the second semester exams. I don't know exactly. I think till now I didn't get the exam timetable, confirm exam timetable. Do you know the date of the exam? Someone asking that. I don't know. Did you receive the timetable?
No, sir, not yet.
So I had the graph timetable, but I did not confirm. No, therefore it is not better to tell the name, a date. So after confirm, the packet will inform the exact date. Okay. Right. So then your target is to find out I2. So then the 7.1. So then I2 means 1 over 1 plus omega minus 1 square. So now we found the two integral values I1 and I2. This is the starting point we have. We have to find out the omega value, no? I denote that equation as equation, think about the equation A, right? A. Then you can write down from equation A. From equation A, we have From equation A we have, what you have, you can substitute the now value, right? A omega equal 1 over 5 into 1 over 5 into the first one I1. You can see the first one I1. I1 means which value is it? I1 means 1 over 1 plus omega plus 1 square. So you can substitute that value here. 1 over 1 plus omega 1 plus square plus, again you can see the I2. I2 means we receive the value. This one, you can substitute that value 1 over 1 plus omega minus 1 square. So now you simplify these two expressions to get the value for A omega. So 1 over 5 into, you can simplify, take the common denominator, 1 plus omega plus 1 square into 1 plus omega minus 1 square. Okay. And when we take this one, we have what is that? Omega square minus 2 omega plus 1 plus 1. And plus when you take this one, you have omega square plus 2 omega plus 1 and plus 1. Am I correct now?
Yes, sir.
Right. Now you can simplify. Plus 2 omega to omega will cancel. This is, we have 2 omega, that means 1 over 5, 2 omega square plus 4 divide by omega square plus 2 omega plus 2 into this one omega square minus 2 omega plus 2 A omega. Then you can take 2 outside of the numerator, 2 omega square plus 2, right? Denominator calculation, what is this? What is simplification of this one? Huh?
4 plus omega 4.
Yes, good. Omega 4 plus 4. Very good. A omega. So then this is actually the what we call integral coefficient we receive, right? So you have to substitute that value for the our transform value. What is our transform value? Integral function. What? So this is the what the integral function we have. So you have to replace the A omega now. Therefore, I denote this one as star equation. Hence, from equation star, we have, for the exams also, we have to keep that in the mind which equation we are going to you are going to refer. That is most important, right? Please denote that number of denote the equations and call that equation when you are going to substitute or maybe the calculate. You can see always I denote the equation, and I mention where which equation you use for calculation and which equation you are going to, for which equation you are going to substitute. That is most important. Other than that, the people who are checking your answers, they don't know what you did, or maybe they are unable to find out your real algorithm. Okay, your calculation. So therefore, please denote that equation and use that equations, or maybe the call that equation when you're going to substitute, right? So then this is the equation I'm going to use. Then the fx equal 0 to infinity a omega means this one now, 2 omega square plus 2 divided by omega 4 plus 4 into cos omega x d d omega should be, I think they are not the alpha, this should be the omega because alpha change as omega, no? This should be the omega. D omega. Sorry. Oh. Sorry. Am I correct now, Krishna? This should be omega, right? Not alpha.